Topic is series combination of the capacitors in second year, fifth lesson. 4 marks is very important. Okay. What is the series combination of the capacitors? We have to take the three capacitors. What is the capacitor symbol? Two plates is equal. Two plates are equal of the capacitors. That is plus Q charge. This one is minus Q charge. Okay. This one capacitor symbol. Here we have to take the three capacitors. Three capacitors of the capacitances C1, C2, C3. Okay. How to connect the series combination? This one is first plate. This one is considered to second plate. Plus Q charge. This one is minus Q charge. How to connect the series combination? Second plate of the first capacitor is connected to first plate of the second capacitor, and second plate of the second capacitor is connected to first plate of the third capacitor, and connected to first plate of the first capacitor and second plate of the third capacitor or last capacitor is connected to opposite terminals of the battery. Opposite terminals of the battery. This is the potential difference V. Plus Q charge minus Q charge, plus Q charge on first plate minus Q charge on second plate. Okay, right. The potential differences in all the capacitors considered to V1, V2, this one is V3 respectively about the capacitors. Okay, here plus or minus Q charge is same. Plus or minus Q charge is same at all the capacitors. At all the capacitors. All the capacitor. The potential difference is different. The potential difference is V1, V2, V3 respectively all the capacitors. Here consider the formula. The total potential drop V is equal sum of the potential. Total potential drop V is equal to sum of the potential drops on the capacitors. That is V is equal to V1 plus V2 plus V3. Consider the equation number 1. What is the capacitor formula? C is equal to Q by V. That means charge by potential. Charge by potential difference. Okay, we can write Q is equal to CV and V is equal to Q by C also. Okay, here we have to convert the V1, V2, V3 formulas. What is the potential difference? V1 is equal to Q by C1. Here plus or minus Q is same at all the capacitors. That is V1 is equal to Q by C1. Then V2 is equal to Q by C2. Next V3 is equal to Q by C3. Substitute these values on the above equation. Therefore V is equal to Q by C1 plus Q by C2 plus Q by C3. Okay. Here Q is same. Q is common. 1 by C1 plus 1 by C2 plus 1 by C3. Okay. This is the V value. Substitute the V value also. That is V is equal to Q by C. Okay. But V is equal to Q by C. Equation number 2. Substitute an above equation. That means V is equal to Q by C. We can write Q by C is equal to Q into 1 by C1 plus 1 by C2 plus 1 by C3. Q is cancelled. Remaining term is 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3. This is a series combination of the capacitor equation. We consider equation number 3. For any, we have to take in the number of capacitors. For any number of capacitors, we can write the formula is 1 by Cs is equal to 1 by C1 plus 1 by C2 plus up to so on 1 by Cn. This is the equation number